Okay, Riles, let's look at sketching transformations of trig functions, like larger combinations here. We'll use a lot of the skills from the previous day. Here we're asked to sketch one labeled cycle of a transformation of a cosine curve. I'm not going to be sketching much of the original curve. I'm not going to be listing all my transformations. I'm definitely not going to be doing a mapping statement. I am ready to start my frame because I know that I have an axis of the curve of y equals -5 and an amplitude of 2. So let's just get a frame on here. That's maybe a little bit taller than I'm usually used to, but I'll see if I can keep the curvature nice. A question like this, I wouldn't require students to list the key features off on the side here, but make sure that you're labeling them. Generally, we expect students to show where every single number comes from. A little -5 plus a 2 here will explain where your maximum of -3 comes from. And a little -2 down there will explain where your minimum of -7 comes from. And I'm ready now to sketch a vertically reflected cosine curve. If I want to sketch one full cycle, to keep my curvature nicer, I could go out of my way to like measure this distance and get closer to where an actual half cycle is going to be, and then quarter cycle here. If these points aren't centered, then my curvature can be a little bit off like that. Yeah, so I'm ready to draw my curve. And this, I think, is maybe a change in the philosophy of how we've drawn things in the past. Usually we would find specific values, and that would tell us where to draw our curves. Now we're drawing the curve first and then labeling where the values are going to occur. This is where I can get into trouble because I've jumped ahead and started labeling my frame, and I can label my curve out of the way. But I kind of want to label this old y-intercept now, and I'm not equipped to see my shift yet. Maybe I should train myself to factor first, to always have that in a factored form. Because I need to have that monic factor right there, just like with long division, just like with finding x-intercepts of polynomials. And checking with distribution, 3 times pi by 3 is going to give me pi. Now, so we are shifted left pi by 3. I'm ready to label that right there. So I have my axis height labeled, my maximum labeled, my minimum labeled, and one input labeled. I'll figure out where my y-axis is, and then I'll decide if I want to plot it or not. Now we have our period to deal with. My new period is going to be a horizontal stretch of my old period. My original period for a cosine curve is 2 pi. And my absolute value of k in this case is 3. Notice I'm not really saying, oh, I'm stretching horizontally by 1/3. I just did, I guess, but I didn't need to. So 2 pi by 3, full period of 2 pi by 3 would bring me to pi by 3 over here, I suppose. Let's go ahead and get our quarter period so we can label all of our key points. 1/4 of 2/3 of pi, let's make our numbers smaller before they get larger, is going to be pi by 6. So let's try this out. This is -1 pi by 3, also known as -2 pi by 6. If I go forward 1 pi by 6, I'll be at -1 pi by 6. Forward pi by 6 from there, oh, I'll be at 0. I guess that's where my y-axis is. And then to pi by 6, and then to 2 pi by 6, also known as pi by 3. Okay. Now there's a labeled cycle of G. G's labeled. Axis heights, all heights are labeled. Inputs are labeled. Yeah, we don't need the independent axis. The dependent axis can be useful when we're solving equations later, so maybe we will sketch it in there. And then another common question, maybe useful for match the graph practice, or has shown up on quizzes or tests in the past, is find a simpler equation for this curve. This is really important for us to recognize, especially for doing match the graph, is that if I gave you this curve and didn't tell you the equation, I bet most students would say, well, it kind of looks like a cosine curve that hasn't been reflected or shifted, or maybe it's a sine curve. So yeah, we have lots of options here. There's an infinite number of possible equations for this curve. I'm seeing it right now as a cosine curve with a period of 2 pi by 3 that hasn't been shifted horizontally. That has an amplitude of 2 and an axis of the curve of y equals -5. If I was asked for a sine curve with the smallest possible phase shift right, then I could do, I don't think this is a simpler equation, but an alternative equation could be a vertically reflected sine curve with an amplitude of 2, a period of 2 pi by 3, shifted right pi by 6, like that. And of course, I need my axis of the curve. Oh, sorry. Yeah, vertically reflected sine curve, amplitude of 2, period of 2 pi by 3, shifted right pi by 6, axis of the curve of y equals -5. If you want to check for yourself, I mean, type all three of these into Desmos. All these curves are going to be coincident. They're not the same equation, but they yield the same curve. They yield the same key points. Okay. Comparing them would also be beneficial. Notice that they all have to have the same Q value. They all have to have the same axis of the curve. They all have to have the same absolute value of A. Sometimes A is negative and sometimes A is positive. That's our choice. They all have to have the same absolute value of K. I would never choose to reflect this horizontally because sine curves are odd and cosine curves are even, so I don't see the need for horizontal reflections. So yeah, absolute value of A, absolute value of K, and Q needs to be exactly the same. And then the things that can change are whether it's reflected or not and whether you have a phase shift or not. Oh, and which model it is. That might help us in the next type of question where we are asked to find an equation for a curve. Let's say a sinusoidal curve has a minimum of 3 at 2. Oh, sorry. Followed by, what's a key word here? An axis point at 6, 8. Let's find an equation for the curve. So things to pay attention to in this question. First off, we're told that it's a sinusoidal curve, so we're not dealing with the tangent function. We're given information about outputs at inputs here. We're told followed by, which will probably wait for a visual to represent. And then let's make sure that we're finding an equation. This has caused problems in a couple of courses where students give me an expression without an output. We're finding an equation. Oh, yes, and then the indefinite article. There is an infinite number of correct answers to this question. You only need to give me one. Might sound like your odds are pretty good then, but there's a larger infinite number of incorrect answers, of course. Let's use our most reliable strategy of drawing a sketch. I think that's just going to help me visualize here. Now, I was not asked to sketch, so maybe I don't need to spend as much time with curvature. Look at this frame. That's not equidistant. That's okay. I have a minimum of 3. That is the output. Minimums are not points, they're values. My minimum height is 3 here. That happens at 2. You could label the point 3, 2 if you like. Then it says followed by an axis point at 6, 8. Maybe we just realize that we know the axis of the curve is now y equals 8. The followed by means I know that there's not an axis point and then a maximum, and then that's an axis point on the decline. That's the next key point right there. Okay. I don't think I'm going to draw the rest of this curve because this is probably enough for me to get all the information that I need. Let's start with the outputs. I can see that my axis of the curve is y equals 8. Therefore, Q has to equal 8. I know I'm shifting up 8. And everyone who has a correct answer must have a vertical shift up 8. Next, let's show my reader how we can find the amplitude here, the difference between my axis height and the minimum height. My amplitude is going to be the difference between 8 and 3. Again, these are simple calculations, but the number 5 doesn't show up on this question, so it's your job to present it for your reader. You may say it seems obvious that the amplitude is 5. I think it's obvious that I want you to show it. Okay. This means that the absolute value of A is 5. Once again, we could receive part marks for listing this information, or you could just get full marks for writing everything in the equation without making mistakes. For the period, we are not seeing one full cycle of the curve. And notice I didn't draw one full cycle of the curve. Maybe drawing one full cycle of the curve would help me realize that I'm given information about points that are a quarter cycle apart. So I'm going to tell my reader what I'm doing. I am finding the quarter period change. 1/4 of my new period is going to be the change in my independent variables. And that means that 1/4 of my new period is going to be 3. I don't really want the quarter period in my equation. I kind of feel like I need to know the full period. Well, my full period here is going to be 12. If I write out my possible equation here, like f of x equals a times sine or the cosine of k bracket x minus p plus q, I might recognize that there's no room for the period in here. This is a very common mistake, students just putting a 12 in here somewhere. But the period is not a transformation. Let's build our formula instead of trying to figure out what I would have to stretch either in grade 11, 360 degrees by to get 12 unitless, or in our case, 2 pi to get 12. We know that our new period is a horizontal stretch of our old period. We know that our horizontal stretch is given by the reciprocal of the absolute value of the k value. Okay. In this question, we know the new period and the old period, or the original period, and we're trying to find k. We do not need to know what the horizontal stretch is. That's key. We can get confused in trying to find the horizontal stretch, or we might accidentally put the horizontal stretch in for the k value. Now let's just multiply both sides by k, the absolute value of k, and divide both sides by your new period. Simple little linear rearrangement. And here's a formula I don't need to memorize because I built this formula and I can just rearrange for how to find my k value. I'm going to say or show my reader that my k value is going to be, let's see, the original period of a sinusoidal curve would have been 2 pi, but I want my new period to be 12. See, I have a hard time seeing that I want to stretch by 6 by pi. I could probably make sense of it, that if my original period was 2 pi, to get it down to 12, I guess I would want to stretch by 6 to get to 12 pi, but then I want to compress by pi to get to 12. I don't need to be that clever, and there's lots of ways that I could get confused there. So let's box our most important information. Q value, A value, K value. And the next piece of advice that I have for you here is to start your equation. Start with these sinusoidal properties. Okay. We should not start by deciding if this has been reflected or not. We shouldn't start by deciding what our phase shift is or whether we're dealing with a sine or a cosine model. You should start with this information because this information is going to be the same for everybody. I'm going to write in f of x equals, I'm going to leave a blank because I don't know if it's been reflected vertically or not, or I haven't decided yet. But I know that my amplitude has to be 5. I don't need 5 to be positive. I don't need 5 to be negative. I haven't decided yet. I'm going to leave a blank because I haven't decided if I want a cosine or a sine model. I'm going to put a bracket. I'm kind of following this pattern right here. I usually decide that I don't want to reflect horizontally. So I'm going to lock in that I want my k value to be positive pi by 6. Okay. I'm going to write my function in factored form because we all know how important that is. I'm going to make sure I have an independent variable. Oh, yeah, right. Make sure I have an equation, right? Not just like that's not an equation. Here's an equation. I haven't decided about my phase shift yet, but I know that my axis of the curve has to be y equals 8, so let's have plus 8. Now, me starting like this might be more from the viewpoint of a marker because these are the first things that I check for. If a student's going to have the right answer, they have to have the correct amplitude, the correct period, and the correct axis of the curve. It should make a match the graph question. a lot faster as well if you can eliminate any options that, say, don't have an amplitude of 5, an axis of the curve of y equals 8, and a k value of pi by 6. The decision of if you want to reflect which model you're using and what you're shifting, all three of these happen together. They're dependent upon each other. And you sort of decide all three of them at the same time. Looking at the information that we have here, I'm going to predict that the two most popular options would be, one, a vertically reflected cosine model. Since the first information that I'm given is the location of a minimum, that sounds like a vertically reflected cosine model. And that means that I would have to, or I could, shift it right 3. So I'll go like that. And I'd predict that that would be the most popular. Now, if you say, how did you know it was a cosine model? Then you're not getting it. I don't know that it's a cosine model. I'm deciding that I want to find a cosine model for this curve. Okay. If we instead maybe saw, if we drew the rest of the curve, some students prefer the sine model. I think the only reason why they prefer it is because they might have seen it first. The cosine model, I hope you've seen in 3U, is more useful for a lot of applications, since we usually have information about when a minimum occurs or when a maximum occurs. Axis instances are a little bit less popular. So I'd say the second most popular option here would probably be a non-vertically reflected sine model with an amplitude of 5, k value of pi by 6, and then we could just shift it right 6, and that would do. Okay. Now, if I'm marking a quiz, I might have an option for a vertically reflected sine model that's been shifted left, I guess shifted left 0, so a reflected sine model, I'll write it down because sometimes students like finding the simplest possible equation, but there's no bonus marks here for doing that. That's a pretty simple equation. It's just I don't see it on my sketch, so I think that's why it's not as popular as some of the others. I don't see much need to, say, figure out what the shift would have been for a non-reflected cosine model. So yeah, record the information that you have. Use your sketch. Try to avoid memorization of formulas. I've seen students try to remember formulas for amplitude and axis of the curve, and you can see what you need to do on your sketch. And then get your reflection, your model, and your phase shift all together at the same time. Give it a shot.